Hi everyone, my name is Dendin Ubusigar. So today I will bring up a topic about coaxial cables. A coaxial cable is a type of guided transmission mediums that designed to carry electrical signals with low interference. For your information, it has a concentric layers of constructions. The first layer is the inner conductor. It is a solid copper or a copper-clad wires that used to carry the electrical signals. The next layer is the dielectric insulator. It is used to surround the conductors to keep it separated to the next layers, while it is maintaining a constant spacing. Third layer is outer conductor. It is act as a shield, and it was made of a braided copper or aluminum coil, which serve as a protect against electromagnetic interference. The last layer is outer jacket. It is a plastic layers that used to insulate and protect the cable from physical damage. So now let's move on to the next topics, which is signal transmission principle. The signals in a coaxial cables is traveled through the inner conductors, while the outer conductors is acting as a return path and shields. Then, the electric materials maintain the uniform spacing to ensure the electromagnetic field is contained within the cables. Then lastly, this cables is designed to minimize crosstalks and external noise, where it is more suitable for high frequencies and broadband transmissions. Alright, let's now talk about the performance characteristics. The first one is the bandwidth. It can support frequencies up to several hundred megahertz. It is suitable for cable TV. The second one is the data rates. It has range from 10 Mbps to 10 Gbps. The third one is the attenuation is moderate. The signal loss increase with length and frequencies around 2 to 10 decibels for 10 meters. The fourth one is the noise or the interference resistance. It has excellence due to the shielding. The last one is the impedance. It has a standard impedance for 50 ohm for data and 75 ohm for videos. Do you guys know that coaxial cables is widely implemented in both analog and digital communication systems? Here are the examples. The first one is cable televisions. It is used to transmit hundreds of TV channels and broadband internet using 75 ohms coax. The second one is internet broadband. It is used by ISPs to connect modems to network nodes. There is numerous advantages of using coaxial cables. The first one is high bandwidth. It has good capacity to support wide frequency range. The second is it has good shielding, where it can minimize signal interference and noise pickup. The third one, it is durable and reliable, where it is resistant to mechanical stress and weather. Lastly, let us talk about the limitations of using coaxial cables. The first one is coaxial cable has a bulky and less flexible than twisted pair cables. Second one is coaxial cables has higher cost per meter than UTPs for short distance applications. Next, the signal attenuations over long distance has to requires amplifiers or repeaters. The last one is it is difficult to install the connectors. To conclude, coaxial cables remains a reliable guided medium, combining high bandwidth and excellent noise immunities. It is ideal for applications like TV cables, broadband internet, and CCTV system. Although fiber optics now dominated for high speeds and long distance links, coaxial cables is still preferred for medium range.
Hello everyone, my name is Merali Arna. I'm from class DEP3A and my number metric is 20 DEP24F1008. So today I will talk about UTP cable, also known as unshielded twisted per cable. So, do you guys know what is UTP cable? Okay, I will explain that. The UTP cable is networking cable used primarily for data transmission in local area network. UTP cable commonly used for Ethernet connection and can contain 2 to 8 pairs of wires, making them a standard choice for many networking applications. The UTP cable is made of copper wires that are twisted together in pairs. The twisting is very important because it helps to reduce interference and crosstalk. All of the pairs are covered with a simple plastic jacket for protection. The cable transmits data in the form of electrical pulses that travel through the copper wire, carrying signals such as data, voice, or even video. For the performance, UTP cable gives good speed and bandwidth for local networks. For example, Cat5e and Cat6 types can support up to 1 gigabits per second, while Cat6a can reach 10 gigabits. However, the signal cannot travel far, usually only up to 100 meters, and it is more sensitive to noise and interference compared to shielded cables or fiber optic cables. The UTP cable. Then, one of the biggest advantages for UTP cable is that it is cheap, easy to install, and very flexible. Because of this, UTP is widely used in our daily life. For example, it is used in internet networks to connect computer routers and switches. It also used in CCTV systems and telephone lines. Most homes and offices today still rely on UTP cable for stable connections. Even though UTP cable is useful, it also has some limitations. It is more affected by interference. The distance is limited to about 100 meters, and the bandwidth is lower compared to fiber optic. In conclusion, UTP cable is a cost-effective and simple transmission medium, although it has some weakness.
In a nutshell, some limitations include higher installation costs and the need for precise slicing and alignment. But overall, fiber optic cables are the backbone of the modern communication because of their speed, reliability, and efficiency. Thank you. For your information, fiber optic cables transmit data using light signal instead of electrical current, making it faster, more reliable, and ideal for long-distance communication. Next, I will discuss about the construction and how the fiber optic cables works. A fiber optic cable is made up of three main parts: the core, which carries the light signal, the cladding, which keeps the light inside by total internal reflection, and the outer jacket, which protects the fiber. A signal is started from a light source like a laser or LED, travels through the core, reflects within the cladding at the other end, converting it back to electrical form. A fiber optic cable have very high bandwidth and can transmit data at extremely high speeds, even terabit per second. They have low attenuation, around 0.2 dB per kilometer, and are immune to electromagnetic interference unlike copper cables. Fiber optic cables are more reliable than copper cables because they are not affected by noise and can cover long distances without repeaters. They are widely used in internet backbone networks, undersea communication cables, data centers, and even fiber to the home broadband connections.